morning, everyone. I'm Ilir, Bejleri with the University of Florida. We wanted to look at the power of visualization to help communities understand sea level rise. So essentially, it's a case study research. We build a number of visualization methods and put them in front of the community, a small community, Cedar Key in Florida. And then using observation notes, comments, comment book, and interviews, basically try to answer our research questions, things like what are pros and cons of each visualization method, synergies among them, interplay with the community, as well as, lastly, the keys to the effective visualization. So the first method we used the 2D, I'm skipping that. The first 3D one is a 3D GIS. We used a number of layers, we used LiDAR to build the terrain, overlaid additional layers, and extracted the buildings on top of it. And then overlaid various sea level rise scenarios ranging from, skip this, I'll show this, ranging from 0 foot, obviously gradually increasing to 1 foot, 2 feet, 3 feet, up to 6 feet. So you can see how gradually the water, it's increasing. And we put this in the screen at a community center there where people would come in and watch it. The next visualization method is use 3D laser scanning to take a small portion of the downtown and model it in 3D very accurately. So we generated a 3D point cloud with a few millimeters accuracy that added photorealism, and also we used that to for the elevation data to build the 3D model. Then once we built the 3D model, this is a view from that model, it's pretty realistic. Then we added some simulation with water on top of the 3D model to basically simulate that sea level rise. Now in this particular case, we simulated flood. We had several scenarios. This one is simulating a flood similar to a hurricane that occurred in this community a little earlier. Different sections of downtown. That's before flood, and then obviously after flood. There's another picture where we put these people on the boat there that related very well to the community. The third model is a physical model. We literally built a tank. Basically 3D printed the terrain, put the buildings on top of it, and then put the water hose there and letting the water come in the tank. This was a big hit, believe it or not. And it's a physical model, right? Nothing of the fancy digital. And it had the community gather around and spark the social interactions and so on. And then last, we actually play a video of the hurricane event itself. So in the same area where we did the modeling, this is to convey the credibility of the science and the credibility that the visualization can in fact convey what's going on in the reality. So the main findings are that the 3D videos were more accessible and more informational than the typical 2D maps. The laser scan added imagery and was very impressive. The 3D GIS was useful because it added the context, and then the actual physical model was memorable, informative, and interactive. It gave them a sense of place. It had them gather together around and discuss the issue. And the video format was useful because it was portable. So at the end, we also found synergies between these models, which I'll skip. Last, in conclusion, we basically found that the 6 key ingredients to visualization are relevance, realism, have community character, interactive components, have ability to spur social interaction, as well as to use as a catalyst